Hello and welcome to Wagner's Tech Talk. While at first glance, this machine appears to be simply a Raspberry Pi 4 laptop running the popular single-board computer. That observation would be correct. It is a laptop, but it's so much more than that. Removing the keyboard will reveal a full electronics lab, which is ideal for developers, educators, students, and anyone who wants to learn about electronics or programming. This is the CrowPi2 by Elecrow. We're going to unbox it, set it up, and explore some of the features of this impressive tech. Let's get started. Let's take a look at some of the features of the CrowPi2. It's got 11.6-inch 1920 by 1080 IPS display. It has a wireless detachable keyboard which connects via magnets. It's got an all-in-one board with 22 plus modules and sensors, a customized learning software on a 128 gigabyte micro SD card, plus RetroPie on a 32 gig micro SD card, a wireless mouse. It's powered by a 12-volt DC adapter or a power bank, a 2 megapixel camera, a microphone, stereo output, and a huge assortment of accessories, especially in the Deluxe kit, which I'm going to show you in this video. I also want to make you aware, if you go to wagnerstechtalk.com/CrowPi2, it'll take you to this page, or you can select the menu option under Raspberry Pi. On this page, you'll find all kinds of information on the CrowPi2, including new things that I've learned after this video was created. Let's go ahead and unbox the CrowPi2s. Actually, just one of them, but I did order 2 space gray, 1 silver. I'm going to be donating 1 to my kids' high school, and 1 for my kids, and 1 for the channel. The kit that we're opening here is the CrowPi2 Deluxe kit, which includes a number of accessories, and this is part of the Kickstarter, although this is the final production unit and not the early versions that you see in mini videos. This is the actual production version. Here's the side of the box, the right side. It's got multiple sensors and making circuits on the included breadboard, animations, and so forth. Here's the back of the box, and down below where it lists everything, I'm just going to show it to you here. Feel free to pause it if you want to read everything that's included in the Deluxe CrowPi2 kit. Very nice. Now let's take a look at the right side of the box. You got RetroPie games, building on Minecraft, remote control vehicles, and facial recognition. Pretty sweet. Here we have the bag that was included in the Deluxe kit, and if you're looking at getting the Deluxe kit for the bag, you may not want to bother. It's not going to offer much protection to your CrowPi2. Let's go ahead and open the box itself and see what all comes with it. First off, we'll take a look at this little flyer here. It's got a little bit of information about the learning material. And here's the user's manual, which has got a lot of good information. Here you see it's covering the development board itself, which I'll show you in just a few moments. It tells you all the sensors, where they're located. It's a very handy reference to have with you. Here's the full module list of all the different modules that you'll see, as well as some of the accessories that are included. There was a flyer that was included. Not much there. And this is a handy little reference chart. I don't know if I'm going to hang it on my wall or not, but this shows you all the components in the basic kit. So it's kind of neat. Shows you the onboard modules. Once again, might be handy to have on your desk while you're working on a new project. There's also lots of these Minecraft cards that you can cut out, drop a little ID tag in there, and do some pretty cool experiments using Minecraft. This is the CrowPi2. I'll just set it aside for now. Let's continue going through the box. It does include a rather nice book on Python programming. Altogether, it has 112 pages. Very good stuff. There's also a book on Scratch, which is a graphical interface type programming, which is a great way to introduce kids to programming. You basically just drag and drop objects to create your programs, and it's very cool. And again, 98 pages. Not bad. Nice material to include in the package. Here we have a set of headphones, which I believe were Kickstarter exclusives. I could be wrong on that, but I believe so. Also included is a mouse. The mouse is wireless, so you will need to use the small dongle that's in here, the USB dongle, and plug that in your Raspberry Pi 4. Next, we have a USB Type A to micro USB cable that you can use to charge the wireless keyboard. And here is a components pack. It's got all kinds of resistors, header pins, jumper wires, switches, all kinds of stuff. Very nice. Here we have a USB-C to micro USB cable. This is for your battery. And this kit does include a battery to power your CrowPi2. There's your game and your system micro SD. The system micro SD is 128 gigabytes and the game is 32 gig. And by game, it means RetroPie. And here we have a wireless IR remote and what appears to be an RFID badge. And some components for hooking up a Raspberry Pi 3B Plus, in case you'd rather use that instead of the 4. Here's a handy USB Type-C Type A adapter to a USB Type-C. Very good to have. And here is our power cable and the power brick itself. This kit does include 2 wired USB controllers. This will come in handy when playing with RetroPie, which, by the way, I'll put a link up above if you're interested in learning more about that. And a micro USB thumb drive. There are a ton of sensors included, so I'm going to go very fast. Here we have the I2C hub, a moisture sensor, an I2C color sensor, an IR reflective sensor, an accelerometer and gyro, a 5-volt stepper motor, a prototyping board, a gas sensor, a basic DC motor with a fan assembly, a red LED, a pulse sensor. This appears to be 10 NFC cards, a servo motor, and last but not least, a set of screwdrivers. Now let's move on to the setup of the CrowPi2 itself. So here we have the CrowPi2. I'm excited to be opening this after waiting about 3 months. This is the Space Gray unit. On the far left-hand side, you have 2 USB 2.0 ports and 2 USB 3.0 ports, as well as Gigabit Ethernet on the right. On the back, you have a storage compartment, which is actually pretty cool, and a fan air intake. So let's push this and pop open the storage compartment to reveal the battery. The battery is a USB-C battery that is 5,000 milliamp hours at 3.85 volts. We'll go ahead and put the battery back in for now. Nice. And just pop it back into the CrowPi2. On the far right, you have a micro USB port for your battery power, a 12 volt for DC, your power button, your volume up and down or brightness up and down. And on the far left, you have your headphone jack right here. Now we'll take a look at the bottom of the unit. Depending on which device you ordered, it may have come with a Raspberry Pi or maybe not. Mine actually did. This is a Raspberry Pi 4 with 8 gigs of RAM. And on the left-hand side is where your micro SD card will go. So you want to just slide your micro SD card into the slot that you see right here. That would be your system or your RetroPie. On the top, you have the connection to the micro HDMI, and on the far left is your power. Now this cable that's running along the top right here, this is for your camera. To experiment with the camera, just plug it into an available USB 2.0 or 3.0 port. Now we'll just attach the bottom cover, and now I'm going to show you what if your Raspberry Pi 4 is not installed. So you basically align the GPIO header pins and pop your Raspberry Pi 4 into place, plug in the power and your micro HDMI, and again, there's your camera. If you don't want to use it, you can just put it up under this location here, and then pop in the screws. Now, one thing I want to make note of is if you look closely, you'll see it doesn't go in the screw holes itself. It's off to the side of the screw holes. The screw holes themselves are filled with small pegs which keep the Pi 4 secure. And once you're done, this is how it looks, fully assembled. You may notice the card that is installed is not the one that originally came with the CrowPi 2. I decided to upgrade mine so there's plenty of room for future expansion. And I'll show you how to image a new micro SD card in just a moment, but I just want to let you know that's what I'm using here. And then once you're done, just go ahead and slide the cover over the back and pop it into place. There you go. In my opinion, it's a good idea to make a backup of your system micro SD card. Whether you're using it for an educational environment or home use, it's good to have a backup copy. And this is something I include in a lot of my videos. But basically, take your micro SD card and put it into a USB reader, then download and install Win32 Disk Imager on a Windows PC, and then click the File Browse icon and enter a file name for your CrowPi2 image that you're going to make a backup copy of. So I'm just going to type in CrowPi2 original system image.img, and then I'll select Open. After doing that, just double check that the correct drive letter is selected and click Read. It will read the contents of the micro SD card and write it to the file name that you specified. And now you'll have a backup copy of your micro SD should you need to restore it for perhaps a new class or just for upgrading to a new micro SD card. Speaking of which, let's do that. Now I popped in the 512 gig micro SD card, and I'm going to click the Browse icon and select the file name of our backup image. Same one we used in the step before. Click Open. And now, making sure that you have the correct micro SD card installed, go ahead and click the Write button on the bottom, and it'll write that image directly to your new micro SD card. Once the write is complete, just click OK and exit. Now we're not entirely done. After you re-image to a new micro SD card, it's actually using the same size as the original. So we need to go ahead and boot up our new micro SD card. Click the icon in the upper left, and then open a terminal window. If you'd like to see the size of the micro SD that's being reported, type df-h, and if you look up here, you'll see that the size is 115 gig. But of course, we just installed it on a 512 gig micro SD card. So let's go ahead and expand the file system. To do that, type sudo raspi-config, press enter, then arrow down to the advanced options and press enter on expand file system. Once you do that, it'll show you this dialog here. Just hit enter. It'll be resized on the next reboot. Hit finish and enter on yes to reboot. And now we'll go back in. I'm going to fast forward through this. And then we'll go back, type df-h again. And now you'll see we're using the full size of the micro SD card at 470 gig with 12 gig used. While we're on the Pi OS desktop, let's go ahead and connect our Wi-Fi. So we'll click this icon with the two red X's. We'll select our SSID. And then type in our passphrase. Press enter. And then shortly after that, it'll connect up to your Wi-Fi network. Now let's take a closer look at the CrowPi2 itself. The keyboard attaches to the base using magnets, and it is wireless, so you will have to charge it periodically. And it charges rather quickly using the included micro USB cable. Alright, so now let's take the screen protector off and take a look at what's under the keyboard. After all, that's probably what you're most interested in seeing. This board is what truly makes the CrowPi2 unique, in that it has tons of sensors and modules that you can use to create your own electronics projects. This is truly an awesome platform for educators as well as parents and children to learn electronics, to learn programming, and to really experience their creative potential in totally new ways. All of this makes it an excellent platform for STEM learning, which is science, technology, engineering, and mathematics. For now, let's go ahead and reattach the keyboard, and it attaches via magnets and holds in place very well. This is the wireless mouse. We'll go ahead and open it up. You'll definitely want to attach this small USB dongle to one of the available USB ports, as it controls both the keyboard and the mouse. Now we'll go ahead and install a AA battery. Your power switch is down here, a very small switch on the bottom. Now we'll go ahead and plug in the DC power and turn on the unit. Alternatively, we could power it by the power bank that was included with the kit, which I've also tried and works very well. But now it's time to check out the software that Elecrow has included in this package, and let's start exploring. The first thing you want to do is click Learning, and then from there, select Create an Account. Type in a name and a password, and you type it in twice, and then hit Next. Then it's going to ask you for a security question. Then simply pick one from the list and give it your answer. I'll just type burger and click Create. And once you do that, your account will be created. Click OK, and then simply log in using your new account. The account it creates is offline, so you don't have to worry about a network connection. Then simply log in, and if you return back to the learning icon here, you will be prompted with 32 lessons of Python programming or 16 for Scratch. We'll go ahead and select Python, and we'll go ahead and go through the first tutorial very quickly. One thing that I really like about this is it's self-paced, so basically you can read the material and step through by clicking the next button. You can go back, you can review the code, and so forth. At various points throughout the exercise, there's a copy icon. If you click that, you can easily copy and paste the code that they show directly into the interface. And from there, you can click the Run button and see the results immediately. You can make changes to the code and repeat the process. As the lessons progress, you're also going to be covering a lot on the GPIO pins, which of course are the general purpose input and output pins of the Raspberry Pi 4 itself. These are the pins that the custom board uses to communicate with all the sensors that are on the CrowPi2. And here you can see I got a warning because I jumped ahead and ran the code before doing the GPIO cleanup. Now after I do that, everything's fine and runs perfectly. At this point, I'll go ahead and click the back button up here at the top, and let's cover some of their sample projects, which are actually a lot of fun to play with. For instance, let's go to this Hello program, and essentially what it's going to do is anytime I say something, it's going to write hello on the LCD display. Hello, CrowPi. Well, let's take a look at a sample on measuring distance. So we'll click Start, and then go down here and hit Run, and it's going to use the ultrasonic sensor to measure distance. So we click OK, and move my hand, and as you can see, the distance is being calculated based on the distance from the sensor to my hand. Next, let's check out RGB Tetris, which uses far more sensors and components in order to play the game of Tetris. Here I'm using a joystick and the touch sensor to rotate the pieces. This is pretty cool. Next, we'll check out an implementation of the game Flappy Bird using the touch sensor. a fun little example. Next, we'll check out a facial recognition example and see if it found me. And it did. This is another intriguing example using the ultrasonic sensor. You move your hand up and down above the sensor and that plays music. And there are more advanced lessons that cover artificial intelligence and voice recognition, speech synthesis, and all kinds of things. There are also a number of Python games that you can use as examples to extend it, using some custom I/O using the GPIO pins, or just play games, I guess, if you want to. And some of them are pretty decent. This game is very similar to Centipede. And of course, there's an extensive number of courses on learning Minecraft on the Raspberry Pi or Pi OS. You won't have the survival mode, but I'm sure kids are really going to dig this. I know if I were 12 again, I certainly would. Next, I'm going to quickly show you the microbit. Basically, we're going to load up a program in the web interface here. So we're going to create a project, and I'm going to steal some code from my website that I used on a robot earlier this year. I'm going to paste it in and download it to the robot. And again, it's going to use the ultrasonic sensor just like we did on the CrowPi2 in order to tell me the distance in inches. Now you know I couldn't let this video end without trying RetroPie. So after I disconnected the camera and went ahead and took the controller and plugged it in, I was able to configure or map each of the buttons on the controller just fine. I connected up my Wi-Fi, copied some games, and after doing that, I simply restarted RetroPie, and now my games are showing up. Now let's go ahead and check out Donkey Kong Country on the SNES. And it looks pretty darn good. If you'd like to see a more detailed video on how to set up RetroPie, I've got one for you. Go to wagnerstechtalk.com/rpi4gaming. You'll find that video plus several more to get you started. I hope you enjoyed this look at the CrowPi2. There is so much more I would like to show you, however, that's it for another video. If you want to see future CrowPi2 projects on this channel, please subscribe or let me know in the comments below. I think it's a fantastic platform for developers, educators, and students. I haven't found any real issues with this unit so far that I couldn't easily resolve. However, check out wagnerstechtalk.com for solutions to the few issues I have run across. Thank you so much for watching. If you enjoyed this video, please click the like button. If you want to see more from Wagner's Tech Talk, please click the subscribe. And with that, I will talk to you very soon.